Now we'll look at some examples with recursively defined sequences. So our question asks us to find the first 5 terms of the given sequence. Our first sequence is a sub n equals 3 times the quantity a sub n minus 1 plus 2, beginning at a sub 1 equals 1. So we've got a sub 1 equals 1. A sub 2, I'll write these out very clearly like I was doing before. So we'll have 3 times a sub 2 minus 1 plus 2. And since we know that a sub 2 minus 1 is 1, we'll have 3, and then I'll go up here and I'll grab our 1 here, and we'll just bring it down there, and we'll have 1 plus 2. So we'll have 3 times 3, which that should give us 9. So now we'll do a sub 3. Same idea, 3 times a sub 3 minus 1 plus 2 equals. Again, we'll grab our output from the previous term, so we'll grab our 9 and we'll pop it down here. So we'll have 3 times 9 plus 2 equals, that's 3 times 11, which should be 33. A sub 4 will have 3 times a sub 4 minus 1 plus 2, which that'll equal 3 times 33 plus 2 equals, what's that, 105. So we'll have 35 times 2, which would be 70, and another 35, so 105. And then lastly, a sub 5 equals 3. A sub 5 minus 1 plus 2 equals 3 times 105 plus 2. So we'll have 107 times 3, which will give us 321. So this is how you find the terms of recursive sequences. The big trick just being you always got to grab what you get out from your previous term and plug that in where you see the n minus 1. Like here it goes there. So now let's do the next one. This next one actually has a special name. The next one is called the Fibonacci sequence. So I'll write that over here for you. Fibonacci sequence. So the Fibonacci sequence is a pretty famous sequence as far as sequences go. This one happens to model a lot of real-world situations. So first, let's go ahead and figure out what our sequences, what our terms are. So we already have f1 equals 1 and f2 equals 1. So f3 will equal f3 minus 1 plus f3 minus 2. So that's our 3 minus 1 will be our f2, and 3 minus 2 will be our f1. So we'll get 1 plus 1 equals 2. So that's the third term in the Fibonacci sequence. F sub 4 will have f sub 3 plus f2. So we'll grab the previous term and the one before it. So we'll have 1 plus 2 equals 3. F sub 5 will have f4 plus f3. We'll have 3 plus 2 equals 5. Now it's starting to grow at a slightly different rate. I'll do one more just so we can see. F5 plus f4 will be 5 plus 3 equals 8. So why this is cool is, for example, just let me draw a pretty bad tree here. So suppose that this line is the trunk of a tree. And I'll draw this black line to indicate where one term ends and the next one begins. So I'll draw another, there you go, that's 1 and 1, and then it branches, we have 2. And if we go to the third, we'll have 3. One of these will branch, so that one does, and this one grows. So then we'll have 5, 1, 2, 3, 4, 5, etc. and so forth. So you kind of get the idea. I can break this up like this, and we'll have 1, 1, 2, 3, 5. Kind of cool. It looks pretty natural as far as, algorithms go for generating real-world looking things. So now we'll move on, just so we don't get too bogged down in these details. Find the nth term of the sequence 2, 4, 6, 8, 16. Actually, I believe this last one is a mistake, so I'll just cross that out. 2, 4, 6, 8. This one should be, this should be pretty straightforward. So we'll call our n a sub n. And it looks like going from 2 to 4, we just add 2. And then from 4 to 6, again, we add 2. And then 6 to 8, we add 2. So we're starting at the previous term. We'll start at a sub n minus 1, and then we just add 2. And of course, we can't forget that we start at the term a sub 1 equals 2. Okay? We'll do one more. Find the nth term of the sequence. 5, negative 25, 125, negative 625. So from this one, we have 5 to negative 25. What's happening here? Well, 25 is definitely a square. That's 5 times 5. So I'll rewrite that as negative 5 times 5. And look at that. It just kind of revealed itself to us. So this is our first term. And negative 5 is what we need to multiply 5 by to get to negative 5. Or negative 25. Let's see if it holds up. So from negative 25 to 125, this is negative 5 times negative 25. So it works. And we'll do the last one too, just to show it. 125 to negative 625 equals, again, negative 5 times 125. So we'll call this one b sub n. B sub n equals negative 5 times b sub n minus 1, starting with b1 equals 5.